Energy. It's everywhere, all around us, used to power our everyday lives, from cars, lights, heating, and yes, the very computer used to animate this production. Welcome to the Energy Mall. Glorious, isn't it? Home to all sorts of different energy stores. 10 to be exact. Now, these aren't your ordinary stores. No fine jewelry and fancy gadgets here. These little guys are not created, nor can they be destroyed. No life insurance needed here then. Now, let's meet the stores. First we have Magnetic. These two are practically drawn together. The relationship has its positives and negatives, but after all, opposites do attract. When these like-minded poles are pulled together, energy is stored. Examples include fridge magnets, compasses, and maglev trains. Now, doesn't that just draw you in? Now, let's pull ourselves away and move along. I'm glad we got away before things got kinetic between them. Speak of the devil, here he is. Kinetic is the energy related to moving objects, the energy of motion. There are many forms: vibrational, rotational, and translational. You look rather worn out and hot. How about we move along? Speaking of hot, this scorching little guy is thermal, the vibration of particles within an object. In hotter objects, the particles vibrate faster. Colder objects vibrate slower, but still have energy. The energy is stored in places like the human body, ovens, and hot coffee. That lit you back up, didn't it? Couldn't have been more perfectly timed. Here he is, light. Light travels in waves, and like his brother Kinetic, light is very fast, the fastest actually. Oh dear. Now here is gravitational potential. Oh, hang on. Gravitational is associated with objects at height relation to its mass. Can we get a medic? Now, where were we? Yes, chemical. Chemical energy comes from chemical bonds, atoms, and molecules interacting. Now, don't be so rude and wait your turn. Sorry about him. He's sound energy. He can be quite loud and intrusive. All right, we will have none of that. It's your turn now then. When an object vibrates, the energy is transferred in the form of a wave which moves through the air before reaching our ears. I wish a wave would take him away. All right, I've had enough of this nonsense. Let's get the last three out of the way. This is electrostatic. Sparky little fellow, isn't he? Ever been walking around in socks and touch something metal and get a nasty shock? Well, blame him. Electrostatic is generated with the movement of electrons. Shocking, isn't it? Now, how about you move along, little fellow? Time is money. Now, who's left? Yes, elastic potential. I thought it'd be a stretch to think this was nearly finished. Now, this rubber head stores energy when he is stretched, squashed, or twisted. So imagine a catapult or inflated balloon. Give us a quick demonstration. That hurried that one up. Oh, you have to be pulling on my arm. I mean, this is nuclear. Now, don't mind him. He's just fission. Nuclear is generated with the nuclear interaction of splitting atoms. The only thing splitting now is my head, however. The fusion of hydrogen and helium in the sun is an example. Now, before you explode or scream or destroy anything, I'm going to make like an atomic bomb and blow off. So, that's the wonderful world of energy. What would we do without energy, huh? What would we do?